In this video, we're going to look at section 8.1. There are two more types of problems we need to cover, and we're going to look at those right now. The first type of problem deals with something called the angle of inclination, which is defined as the angle measured from the positive x-axis to the line. Here we can see we have an angle in the first quadrant, but let's take a look at what happens if the angle is in the second quadrant. If we try to relate this to the unit circle, and I've drawn some x and y axes here, we can see that this angle, or this line, causes an angle of inclination that's in the second quadrant. You can see it goes up here. If there's an angle that's greater than 90 degrees, or in other words, does fall in the second quadrant, we know that line is going to have a negative slope. Due to this, no matter which line we choose, our theta, or angle of inclination, will be between 0 degrees and 180 degrees. What we now need to do is take a look at how this relates to trigonometry. If you focus on this triangle in here, and we move this and kind of look closely at this triangle, what we can see is that the tangent of theta, which is how the angle of inclination is going to come into play, we know that the tangent of theta equals y over x, or in terms of SOHCAHTOA, it's opposite over adjacent. If I label these sides, we have x, y, and r here. We can also see that in terms of the slope of this line, the tangent also equals rise over run, which means the tangent of theta equals the slope of the line. We've established now that the slope of the line is the tangent of the angle of inclination, but how can we solve for the angle of inclination itself? Well, if we just take a look at this equation right here, we know from last class that to solve that you would take the inverse tangent of both sides, leaving us with theta, or the angle of inclination, equaling the inverse tangent of our slope, or m. This is going to give us the reference angle for which we need to fit into here, where theta has to be between 0 degrees and 180 degrees. If you're given a negative angle, and we'll take a look at one of these examples in a second, you want to take 180 degrees, subtract the reference angle, and that will give you your angle of inclination. So let's take a look at this example here. If we make some room for ourselves, it says, what is the angle of inclination of the line y equals negative 4x plus 9? Well, we know the slope here is negative 4. So in order to find our angle of inclination, we know we need to take the tan inverse of negative 4. Since our range here is given from 0 degrees to 180 degrees, I need to make sure my calculator is in degree mode. And when I take the inverse tangent of negative 4, I end up with theta equals negative 75.96 degrees. However, this doesn't fall into this range. So what can we do about that? Let's take a look at a picture. If I told you to draw a negative 75.96 degrees, you'd probably throw it somewhere down here. If we extend this line, let me change the color here so you can see it. We know that this is going to be negative 75.96 degrees. We want this angle right here. In order to solve that, we can do 180 minus 75.96 degrees. And that's going to leave us with our final answer, which is going to be 104.04 degrees as the angle of inclination. So if we take a look at a few more examples of the angle of inclination problems, the first is asking us for the angle of inclination of a line joining the points negative 3, negative 5, and 3, negative 3. Well, the first thing we need to do is find the slope of those lines. We can do that by doing y2 minus y1 over x2 minus x1. These end up both being positives. We end up with 2 over 6 or 1 over 3, which means all we have to do is take the tan inverse of the slope, which in this case is 1/3, and we arrive at our answer of 18.43 degrees. For the second problem, it's asking us for the angle of inclination of the line perpendicular to y equals 3/4 x minus 8. First things first, perpendicular slope we know is the opposite reciprocal, so the line perpendicular to this line will have a slope of negative 4/3. When we take the tan inverse of negative 4/3, as we saw in the example on the last slide, it's going to give us a negative angle. Here we get negative 53.13 degrees. Again, that's not in our range. We know that theta needs to be between 0 and 180 degrees. So if we take 180, subtract 53.13, our angle of inclination here is 126.87 degrees. Hopefully these problems have given you a pretty good understanding of angle of inclination and how we can use it. We'll take a look at some more problems in the next class. We have one last type of problem we need to talk about in section 8.1. Looks a little bit like what we started with in class today, but there is one minor difference, and you can see right here is this 2x. We haven't seen anything quite like that before. So we're going to start solving this just like we would any other problem. If we divide by 12, we have the cosine of 2x equals 7 over 12. Next, if we take the cosine inverse of both sides, we end up with 2x on the left and the inverse cosine of 7 over 12 on the right. We'll notice that our domain, is given to us in radians, so our calculators need to be set to radians. We end up with 2x equals 0.95 as our first answer. Now, how does this change? We have an x over here in our domain, but this is in terms of 2x. So what we need to do is convert our entire domain in order to match the 2x. So each piece of the domain needs to be multiplied by 2. The only thing that changes in this case is that instead of 2 pi, we're dealing with 4 pi, which of course is 2 rotations around the circle instead of 1. So if we look at our possible answers, we know we have a cosine function, we know it's positive, which means we have to be in quadrants 1 or 2. However, since we're going twice around, we're going to have 2 answers from quadrant 1 and 2 answers from quadrant 2. So our first setup here is 2x equals 0.95. In order to find the angle in quadrant 2 with a reference angle of 0.95, we want to find pi minus 0.95, which gives us 2.19. So now we have one answer in quadrant 1 and one answer in quadrant 2. Since we can go around the circle one more time, because our domain ends in 4 pi, we want to find an angle that is coterminal with each of these. If you remember back from section 7.1, in order to find a coterminal angle, we can add 2 pi to each of these. We add 2 pi to 0.95 and to 2.19. We end up with the following to round out our answers. The one last thing we need to account for here is our answers need to be in terms of x. We would never write 2x equals something as a final answer. So what we can do here is simply divide all of these by 2, and we'll end up with the following for answers. X equals 0.475, 1.095, 3.615, and 4.235. So once again, we started with this 2x in our problem. What it did was expanded our domain. By doing that, we doubled the number of answers that we're used to, and we ended up with 4 answers. So let's look at one more of these without a calculator. Slide this out again. We're 0 to 2 pi, so we're once again in radians, and we have negative 2 cosecant of 3x equals 4. So as we start, we know that the cosecant of 3x equals negative 2. If I divide out the negative 2 on the left, we know that cosecant and sine are reciprocal functions, so this also tells us that the sine of 3x equals the reciprocal of negative 2, which is negative a half. Take the sine inverse of both sides, and we're left with 3x equals the sine inverse of negative a half. When we take the sine inverse of negative a half, we know sine inverse has to come from quadrant 1 or 4. However, since the sine is negative, we're going to get that angle from quadrant 4. So our reference angle here is going to be negative pi over 6. Figure that out by either memorization or using the hand trick. We're looking for the reference angle when the sine is 1/2, which is 30 degrees or pi over 6, in this case negative pi over 6. Now, we do have to account for that 3x. We know our domain is going to change. We multiply the entire domain by 3, we get 0 is less than or equal to 3x, which is less than or equal to, in this case, 6 pi, which is 3 rotations around the circle. If we look back to this line up here, we have a sine of something equaling a negative, which means our answers could possibly come from quadrant 3 and 4, where sine is negative. Since we have 3 rotations, we're going to end up with 6 possible answers here. So our angle in the third quadrant is 7 pi over 6. Typo there. And our angle in the fourth quadrant is 11 pi over 6. Now, from there we need to find angles coterminal with that until we get to 6 pi, which means we're going to need 2 for each. So we know that this is one of our answers. We know that this is going to be one of our answers, at least those that equal 3x. We are going to have to divide everything by 3 at the end. If I add 2 pi to find something coterminal, I can write 2 pi as 12 pi over 6, and I end up with 19 pi over 6. If I add 12 pi over 6 down here, for my second circle, I end up with 23 pi over 6 as one of my angles. Again, 6 pi, we need 3 rotations. We need to add another 12 pi over 6 to both of these. This gives us 31 pi over 6. We add 12 pi over 6 down here. We get 35 pi over 6. Again, these all equal 3x. There's the key. We need to divide each of these by 3 or multiply them by 1/3. Kind of move up here, we end up with 7 pi over 18, 11 pi over 18, 19 pi over 18, 23 pi over 18, 31 pi over 18, and finally 35 pi over 18. Again, 6 answers, kind of a lot of work, no calculator, but that question should be pretty fair game. So why don't you try one of these on your own? You can use your calculator for this. One thing to note before you start is that we are in degrees. So you're going to want to switch your calculator to degrees, and your answer should be in degrees as well. So let's see how you did. If we take a look at this problem here, we have 3 secant of x over 2 equals 7. How would we solve this? Well, first we would divide by 3. So we end up with the secant of x over 2 equals 7 over 3. Again, we need reciprocal functions in order to take the inverse in our calculator. We know that the cosine of x over 2 is going to equal 3 over 7. By taking the cosine inverse of each side, we end up with x over 2 equals the cosine inverse of 3 over 7. What we do when we get that, we get x over 2 equals 64.62 degrees. Now once again we have to adjust our domain. Since over here we're in terms of x over 2, we need to in this case divide by 2. So our domain changes from 0 degrees to x over 2 to 180 degrees. So since we've restricted our domain to just the top half of the circle, or just quadrants 1 and 2, the cosine is only positive in one of those quadrants, quadrant 1, so we are only going to have one answer here. Our last step is to multiply that by 2 in order to put it in terms of x. We end up with 129.24 degrees. So once again, these are a little bit tricky. We'll look at a couple more of these in class and then get a lot of practice in. But hopefully this video was helpful for you.